Greetings, YouTubers and fellow AI enthusiasts. My name is Erwin, and this is RadHorizon. Happy New Year. It's been a while. I've been really busy with work lately, but I always wanted to make a short video regarding AI and machine learning ethical issues in medicine and radiology. I was recently privileged enough to attend an amazing lecture by Professor Andew Ng last December 2019 under the collaboration of AI Pilipinas and DEEPLEARNING.AI. I'm really thankful that people like Professor Andew are willing to share their experience and knowledge to the rest of us. The lecture was mainly about AI and machine learning ethical issues in general, but it made me realize that ethics can have various interpretations depending on the domain in which AI is applied. It's for this reason that I decided not just to make a summary of that lecture for this video, but instead to focus on my own interpretation or reaction to the lecture with regards to my particular domain, mainly medicine and radiology. Again, I would like to reiterate that these are based solely on my opinions and do not reflect the ideas or opinions of the groups or institutions that I belong to. So let's get this started. Thank you.
Five basic issues discussed during the lecture that made the most impact on me were the following: bias, deepfakes, adversarial attacks, adverse use cases, and impact on jobs. Let's discuss bias first. One example of this in medicine would be where a medical algorithm allegedly favored white patients over black patients. The algorithm wasn't specifically trained to be racist, but with data it was given, it somehow ended up with this kind of clinical outcome. There are two links in the description down below if you want to read about these. These aren't exactly related to radiology, but it's interesting to note that even with apparently neutral data, if we're not too careful, racial features may still be extracted by algorithms, even if it was not the primary intention. I'd like to discuss deepfakes, adversarial attacks, and adverse use cases as one, since I think there is one terrifying example or proof of concept that encapsulates all of these, and that is the ability of an AI algorithm to add or subtract pulmonary nodules from a set of CT images. There is a link to the YouTube video of the proof of concept in the description down below. The scary part about this is that if allowed to happen, this can have damaging, if not devastating consequences to the treatment of a patient. Patients who might want to pass a medical screening and exam can have this done and not get the proper treatment, which can endanger not only themselves, but others as well. The converse is equally as scary. A normal healthy patient might have his medical data attacked by an unknown entity that will result in unnecessary treatment or even prevent him from going to work or living a normal life, all because of a false diagnosis or a deep fake. Let's discuss impact on jobs next. I'd like to quote the following. While about 400 AI companies has sprung up in the last 5 years, the number of radiologists who have lost their jobs stands at 0. It comes from a well-respected radiologist and expert in medical AI. You can read more about it in the link down below. There's a constant need right now to replace the human being with AI. There's a need for driverless cars, chatbots, replacing call center agents, but there is this great, huge drive for some reason to prove that AI outperforms doctors or radiologists in particular, especially with the whole new study on breast cancer imaging detection. Discussing that would be beyond the scope of this short video, but I would like to say this. As I have read and gathered from other experts in medical AI, it's very important to stress that model performance is not the same as clinical outcome. Being able to prove that a machine learning algorithm can outperform a doctor given a controlled instance in time does not mean that it will automatically be as effective in a hospital or in a clinic. Think of it this way. Model performance testing is like testing a product in a factory. Even the best smartphones can have great results at factory tests, but the true proof of the pudding is in the field tests, and that is the hospital. Hospitals are dynamic workplaces, and population demographics shift constantly, resulting in concept or population drift. Current AI and machine learning models do not retrain as they infer and can be very susceptible to these changes. Anyway, my point is that instead of focusing on AI beats or replaces doctor, driver, call center agent, or human in general, I hope we focus more on AI helping humans in general. Let's build AI that helps us live our lives. In the lecture, we also discussed 5 points from the global landscape of ethics. The link to the paper is in the description down below if you want to read it. There were more points in the paper, but the 5 points I'll be discussing in this video are: number 1, transparency; number 2, justice and fairness; number 3, non-maleficence; number 4, responsibility and accountability; and finally, number 5, privacy. One important message of the paper which struck me was that there is a great divergence in how these principles are interpreted or deemed important depending on the domain to which they are applied. For this video, I'll be focusing on my domain, which is medicine and radiology. I could explain all 5 point by point, but I think a more concrete way of elaborating how these apply to medicine and radiology would be with a user story. Let's begin. An AI machine learning vendor usually packages AI with its PACS system. This is a picture archiving software system used in organizing medical image data for either a hospital or clinics. This costs millions, so usually only hospitals or large clinic systems can afford it. Let's say the vendor goes to a hospital and sells its AI solution. Usually, an initial sales pitch might include how accurate the machine learning or AI model is, and you get amazing numbers like 90% or 99%, or even how it outperforms doctors given specific and well-controlled conditions. These all sound really good on paper, but an entire argument can be made on how these are not the best metrics to determine clinical outcome. Regardless, all of these numbers have less to do with point number 1, which is transparency. So what is transparency? For me, as far as my understanding of the paper and radiology is concerned, transparency refers to explainability and interpretability. AI and machine learning models are basically considered as black boxes. You really don't know what's inside or what they're thinking. They can point out a lesion they were trained to detect or classify, but they won't tell you outright why they pointed out that lesion. In terms of a radiology resident in training, this is best exemplified as the following. My mentors in radiology would usually test me in a particular way. First, is there a lesion? This is basically image classification, or classifying the image as either positive or negative for pathology. Second, where is the lesion? I would then point to the lesion. This is object detection. And then comes the clincher. Why is that the lesion? Why am I pointing to that? What is wrong with that? Why that part of the image? The why refers to explainability and interpretability. A machine learning model can draw a box around a lesion and classify it, but why does it point to that? Why does it classify that as pathology A, B, or C? This is the realm of explainability and interpretability, to shed light on what is inside the proverbial black box of the AI model, to shed light on how it is trained. What data was fed into it to make it classify or detect objects the way it does? These all fall under transparency. The why do you think that way? What kind of data did you train on? What type of neural architecture was used for you? Justice and fairness, as well as non-maleficence, are pretty straightforward. We try to minimize unfair, self-serving human bias that can be wittingly or unwittingly introduced to the algorithm, like in the case of the medical algorithm favoring whites over blacks, even if that was not the intention from the data being processed. Non-maleficence is best exemplified by avoiding cyber attacks like the proof of concept, where pulmonary nodules can either be added to or subtracted from chest CT scan images. We've discussed these before with the prior examples, so I'll go on to the next. Let's go to number 4, responsibility and accountability. Let's go back to our user story. The AI vendor sells the AI solution. The hospital invests and installs the AI solution. Now let's go to an actual use case. A radiologist is on duty. It's 3 a.m. in the morning. He's tired. He looks at a radiograph. Even if he's tired, his years of experience tells him that this X-ray of the hand is negative for fracture. Takes less than 5 minutes, or maybe even less than 1 minute if he's really confident. It should be over and done with. But now he realizes that there's an AI algorithm he can use during his tour of duty. What does it say? The algorithm puts a bounding box around a small lucency along one of the bones and says there's a 50.5% chance of fracture along that area. The radiologist looks at the bone and considers it a vascular groove. It's nothing. And yet the algorithm says 50.5% chance of fracture. What does he do? There's an argument that whatever happens, the human should bear all the blame since he makes the final decision, and he's the doctor. So okay, let's follow that argument. The human is to blame. Now let's take on the AI outperforms doctor hype train. If AI outperforms doctor and is used as a screening tool, or basically you let the machine do everything without human supervision, if the machine makes a mistake, who takes the blame? The AI vendor? The data scientist who prepared the data? The data engineer who constructed the neural network? There's a long list of people that make up the machine learning pipeline. When an AI machine learning model is sold to a hospital or a clinic, who ultimately is responsible for the model if it fails, or worse, ends up hurting a patient? Therein lies the question of responsibility and accountability. Let's go to number 5, privacy. AI or machine learning models need data. They need to learn from something. And since we're talking about medical data, this all boils down to human data. So the question now is, before images are used for training, do people get a say in how their information is used? Shouldn't they be aware that their personal private medical images are being used to train an AI machine learning model? Should they be informed as to how that model will be used? There are currently free AI platforms right now that allow free use of their AI. You only have to upload your image to the cloud. So the question there is, are you really getting to use that AI model for free? Or is that platform getting your image data for free? Whose privacy will be put in danger given these free-to-use AI systems, where the model resides in the cloud? In my opinion, a safer platform would be where the model itself is downloaded to your local machine, so the private data is never uploaded to some other person's computer in the cloud. An interesting group or website regarding AI ethics was also introduced to me during the lecture, and this would be the OECD AI Principles. OECD, or Organization for Economic Cooperation and Development. There is a link to their site in the description down below. So the Code of Medical Ethics was touched upon briefly in the lecture. It was noted that medicine had to go through years to continuously refine these ethical values. The question remains if AI will have to go through the same grueling path before it can formulate its own more standard or universal set of ethical guidelines. With regards to medicine and AI ethics, one question was raised during the lecture, and it was this: should a known human rights violator be allowed to study AI in a university? In medicine, there's usually a screening board that helps decide if a candidate or applicant is psychologically sound or even prepared to train as a doctor. But do AI universities have this? I personally started learning AI and machine learning on the net. Unlike medicine, which needs actual human interaction, the basics of AI as well as the code are freely available on the internet. Just my thoughts on this question. If these people are not allowed to go to university for AI training, can't they just go elsewhere? Online, where there are fewer restrictions and even more possibilities, whether good or bad. Again, I'd like to thank AI Pilipinas, Deep Learning AI, and Professor Andrew for allowing me to learn from an amazing lecture. If there's any take-home point from that entire experience, it was the advice to go out and discuss AI ethics with the world. We should discuss this now and be more open to various ideas and perspectives, not just from medicine, but from other domains. My ideas might not be entirely correct, and the reason for discussion is to open our minds to the wondrous possibilities as well as dangers of AI for our future. So if you have your own ideas, feel free to comment down below. I'd like to hear from you all. If you enjoyed this video, please give it a thumbs up or hit subscribe.
So that wraps up my short video. I'd just like to end it all by saying that AI, machine learning, technology, these are all just tools at your disposal. In the final analysis, you are the ad hoc razor. You are the rad edge. Thank you.